in the denominator here, I can't have that. But it's not just an I by itself, it's a 1 plus I. So that one's one of the ones that requires us to use one. Got to use a conjugate. So I have to multiply this one by what?
1 minus I.
1 minus I over 1 minus I. Right? That's a pretty fancy one in disguise. Okay? That one's got like a bowler hat. So good. Okay? So when I multiply this one, I just get to distribute the top. So I'm going to get 8 minus 8I. And then in the bottom, I have to actually FOIL this. So 1 times 1 is 1. 1 times negative I is negative I. I times 1 is I. And I times negative I is negative I squared. All right, the good thing is that these i's cancel. And what is I squared?
Negative. Positive 1.
Yeah, well, I squared is negative 1, but this is minus a negative 1. So that's a plus 1 down there. So now in the top, I've got 8 minus 8I. But in the bottom, I've got 2. Now, all of these things are even. So I can simplify it to be 4 minus 4I over 1. But you don't need the over 1. But if you put it in there, I wouldn't mark it wrong. That's good enough. 58. Negative 5 minus 3I over 4I. All right, how many people multiplied by negative 5 plus 3I over itself? Okay. It's okay to have a nasty top. You can have all the i's and radicals you want up there. It's the bottom that's the problem. All right, so I can't have the I down here. All right, now that I is pretty much alone. It's by the 4. So what can you multiply by in order to get rid of it?
You multiply by itself. 4I over 4I.
Okay. Now, do you actually need the 4? No, because the 4 is not really a problem. If you use the 4I over 4I, you're just going to have more simplifying at the end, but it's not wrong. Right? But if you want to have less simplifying at the end, just multiply it by an I over an I. That's a very simple one. But if you did the 4I, no harm done. You're just going to have more simplifying at the end. Okay. So when I distribute the top, I'm going to get negative 5I minus 3I squared over 4I squared. So what do I really have down here? Negative 4. And then what is this? Positive 3. All right, so now in the top I've got 3 minus 5I. And I just flip the order there. And then I have a negative 4 in the bottom, and that one is now acceptable. Right? If I would have done this one, multiplied by 4I over 4I, that's still a 1. But it's a little bit more of a 1 than I need. But it still works. So if I multiply here, I'm going to get negative 20I minus 12I squared all over 16I squared. What do I really have in the denominator here? Negative 16. And then in the top, what is this really? 12. So we get 12 minus 20I. What do all 4 of those have in common? 4. So I can go 3 minus 5I over negative 4. You get the same thing, except you don't have to do the simplifying step here if you just use the I instead of a 4. But it's up to you. 62. Okay, square root of 10. And then the bottom, this is the worst disaster of a bottom that we've had. Right, because not only am I not allowed to have radicals in the denominator, I'm not allowed to have i's, and I got both.
So let's just find that.
All right, so multiply by what?
10 plus I.
Square root of 10 plus I. Square root of 10 plus I. The good thing about conjugates is it picks i's and radicals. And it'll do both. So when I multiply up at the top, and I have to distribute this through, what's the square root of 10 times the square root of 10? 10. Square root of 10 times I?
Square root of
square root of 10. Okay, and then down in the bottom, I have to actually FOIL this one. So square root of 10 times square root of 10, is that one. Square root of 10 times I
times square root of 10.
Okay, and then negative I times square root of 10.
Negative square root of I times square root
right? And then negative I times I. Negative I squared. Now the next thing there is, these cancel, and I still have an I in the denominator, but it's a negative I squared, which is really plus 1. So that's out. So now I've got 10 plus
I rather 10 over.
There you go. And the last one, you guys wanted to see, 6 minus I square root of 2 over 6 plus I square root of 2. What am I going to use for a conjugate?
6 minus I square root.
All right, so FOIL these. All right, bottom first. 6 times 6 is
36.
6 times negative I square root of 2.
Minus 6 I square root.
6 times the positive I square root of 2.
Plus 6 I square root.
The next thing there is that this monstrosity is gone. Then over here I've got negative I square root of 2 times an I square root of 2.
Minus 2 I square root of 4.
Okay. I think everybody said something right and everybody said something different. But they were all right. They were just in various stages of simplifying.
He just said,
Okay.
yeah, he just said.
So the I times the negative I squared, and then square root of 2 times square root of 2, square root of 4, which is 2. I heard them all. They were all over the place. That's right. So I get this. Right? And then in the top, right, 6 times 6, still 36. 6 times this one.
Minus 6 I square root.
All right, and then this one,
Minus 6 I square root.
same thing again. And then here,
Plus 2 I square root.
2 I squared.
Square.
Right. Okay. All right, now, up here, let's look at these two things. How many I square roots of 2 do I have? I've got 2 terms with them. All right, but I've got negative 6 here, and I've got negative 6 of those here. Like, I know that this is kind of, you got to think outside the box a little bit here. That
2I.
and this, you need to think of like just being a variable. So like if I had negative 6x minus 6x, you would have negative 12x. So
Negative 12.
right, so you have negative 12 ugly thing that they've got in the box. Okay. All right, and then I still have this 36, and then what is this really? Okay, I'll come back and simplify that in a minute. So down here I've got 36, and then what is this? Positive. All right, so in the top I'm going to get 34 minus 12I square root of 2. And in the bottom I'm going to get 38. All of these are even. So 17 minus 6I square root of 2 all over 19. Any other ones? Yeah. Before we start completing the square here, these 3 review problems, I would like you to do them for me. All right, solve these 3. All right, and that shouldn't take you too terribly long at all. So, can you factor them? And give me x or find my x's. And I'll give you guys a couple minutes to do those, but these should be on autopilot. Autopilot. All right, I'm going to go through these really quick. So if I factor these 2 things, I get an x plus a plus, multiply together to get 4, add together to get 4. 2 and 2. So this is really like an x plus 2 squared. Okay. How about this one? What do I do first?
Add 9.
Okay. Again, x squared minus 6x plus 9 equals 0. All right. X minus 3. So I get x minus 3 squared. All right. It looks like this one might do the same thing, right?
Wrong.
But so if I start trying to factor it, I got an x, a plus, multiply together to get me 20, add together to get me 10. No, I can get close though, right? Like with 4 and 5, right? How is this one different than these? What are these two? If you look at this one and this one after we fixed it, what do these two have that this one doesn't? See any relationships in there? Well, this one has a plus plus. That one's a plus plus. This one's a minus plus, so it's a little bit different. Well, what happened here that happened in both of these?
I'll do the same.
I ended up factoring it out, and I got the same thing twice, right? Why did that happen?
Yes. No, they're not.
There are perfect squares involved somewhere. Where? The 9 and the 4. The constant was a perfect square. How did that end up being related to the middle term? Right, because if you take the square root of each one of those and double it, you end up getting those, right? Right, that did not happen down here. What would this number have to be in order to make that happen? What is it? 25. 25, right? So that's what completing the square is all about, is this is what I wish it were, I'm just changing it. Yeah, I'm going to do my own thing,
Yeah.
okay? And that's kind of what completing the square is.